Imagine meticulously documenting a single garden for years, like writing 910 separate journal entries.
That is a massive undertaking.
Right, only to become utterly obsessed with a flower that vanishes in 24 hours.
Yeah, it really challenges how we think about value.
Exactly. I mean, why would an expert dedicate their life, or at least a huge portion of their daily routine, to something so fleeting?
It's a great question.
Because our modern instinct is to, value permanence. We want buildings that last centuries, software that scales forever.
Unchanging foundations.
Yes. So when you encounter someone who has mastered observation, yet chooses to focus on a biological event that literally disappears overnight, it forces a complete reevaluation.
It completely challenges the framework of how we pursue knowledge, really.
How so?
Well, we're conditioned to seek out these heavy, monumental triggers for learning. We expect profound wisdom to come from dense, thousand-page texts or massive life events.
Right, the earth-shattering moments.
Exactly. But stepping into the world of quiet, daily observation reveals a completely different architecture of learning. It's built on the slow, deliberate accumulation of tiny details.
And sometimes the most ephemeral subjects yield the most durable lessons.
Precisely.
Well, welcome to today's deep dive. If you're tuning in right now, you are likely that perpetual learner who is always trying to figure out how the pieces of the world fit together.
You're looking for those hidden aha moments.
Yeah, but you want the actual mechanisms behind them, not just the fluff. So today's mission is to explore how profound insights about patience and ephemerality and resilience can be decoded from a single, incredibly short journal entry.
And this is very recent material.
Hot off the presses. It was published just yesterday, May 30th, 2026, by an author named Ang.
Yeah, we're looking at an excerpt from a series called The Golden Bloom of the Yellow Alder. Specifically, it's a post titled Notes on Gardening, Part 910, detailing Ang's encounter with the yellow alder. Biologically, that's classified as Turnera ulmifolia, also commonly known as the sage rose.
I saw that title and my jaw actually dropped.
Yeah.
Okay, let's unpack this. Part 910.
It's staggering.
It really is. Think about the sheer uncompromising dedication it takes to write 910 parts of a gardening journal.
Yeah.
Whether you, the listener, are trying to master a new programming language or learn to paint or optimize a supply chain, maintaining that level of documented observation it changes the gravity of the text.
It's not just a casual social media post.
No. It is the output of a masterclass in sustained attention.
And if we connect this to the bigger picture, examining a hyperspecific passion project of this magnitude provides a universal blueprint for your own learning process.
Oh, absolutely.
This single entry really transcends botany. It serves as a map for how an expert learner processes the world, categorizes new info, and synthesizes it.
So the first major takeaway from Ang's entry centers entirely on the timeline of this process.
The long arc of observation.
Right. Ang starts the entry by asking the reader this simple question. Do you still recall in part 755 when I first spotted the yellow alder or sage rose?
That gap is fascinating.
It builds an immense amount of anticipation. Ang first spots this plant in part 755, but notes that it was only during a recent trip, over 150 entries later, that they finally saw one in person at its absolute peak.
Yeah, that patience is key.
It's like having a concept sitting in your mental browser tabs for years.
Yeah.
You open the tab because the idea is intriguing, but you just let it sit there in the background.
Until the environment finally provides the perfect opportunity to see it work.
Exactly, to see it in the real world.
That mental browser tab analogy actually has a robust foundation in cognitive psychology. It's known as the Zeigarnik effect.
The Zeigarnik effect.
Yeah. Back in the 1920s, a psychologist named Bluma Zeigarnik noticed that restaurant waiters could remember incredibly complex, unpaid orders perfectly.
Oh, wow.
But the moment the bill was settled, the information just vanished from their memory. The human brain is actually wired to remember uncompleted or interrupted tasks significantly better than completed ones.
So by spotting the sage rose in part 755, but not mastering it right away, Ang basically opened a cognitive loop.
Precisely. And holding an unresolved question in your mind for that long creates a state of passive curiosity.
It just sits there, quietly keeping the brain primed.
Yeah, Ang didn't force the learning process. There was no rush to buy seeds or build a synthetic greenhouse and demand the plant perform immediately.
In an unnatural environment, right?
Exactly. Ang allowed that zygarnic loop to remain open until the recent trip naturally provided the peak specimen.
Which highlights a huge flaw in how we usually approach learning today.
We rush it.
Yeah, we discover a new concept and feel immense pressure to instantly internalize it, to force closure on that cognitive loop before we've even seen the subject in its natural peak state.
Like trying to memorize the textbook definition of crisis management without ever having watched a great leader navigate an actual crisis.
Yes, the tab is open, but you're trying to force the aha moment in a vacuum. So the years-long wait from part 755 to 910 means that when Ang finally encounters the flower at its peak, the visual impact isn't just like a pretty aesthetic moment.
It's the biological closure of a massive cognitive loop.
Exactly. Ang describes seeing those vibrant yellow flowers contrasting against the waxy foliage. Picture that high-contrast visual for a moment.
Striking.
The vivid, almost neon yellow exploding against dense, glossy green leaves.
And that visual contrast isn't just aesthetically pleasing. It is a profound indicator of the plant's evolutionary strategy.
The waxy leaves.
Yeah, those waxy leaves, Ang observed, are a critical biological mechanism. The outermost layer of a plant's leaves, the cuticle, is synthesized by the epidermal cells.
Okay.
And it consists of a complex lipid polymer called cutin, which is heavily embedded with waxes.
So it's basically armor.
Exactly. It creates a highly hydrophobic or water-repelling barrier.
Yeah.
In harsh environments, this waxy armor is what prevents desiccation. It locks moisture inside while defending against pathogens.
Here's where it gets really interesting. Because of that years-long anticipation, Ang doesn't just passively admire this evolutionary strategy.
The reaction shifts instantly.
Right. From mere observation to active scientific ambition. Ang writes, I would definitely grab a few specimens for evaluation and propagation if I had the chance.
That's the expert's impulse.
The sight of the peak specimen immediately triggers the impulse to take it apart, to capture it, and to multiply it.
This is the defining impulse of the expert learner. When you witness a concept functioning perfectly, you want to replicate it.
Whether it's a botanical specimen or a piece of code.
Exactly. You want to propagate it. And in botany, propagation relies on a cellular phenomenon known as totipotency.
Totipotency.
Right. Unlike most animal cells, which are locked into being a specific type of tissue once they mature, many plant cells retain the genetic potential to divide and regenerate into an entirely new, fully functional organism.
So when Ang wants to grab a specimen to propagate, they are planning to take a piece of a leaf or a stem and literally force those cells to completely reprogram themselves from being stem to being root.
Yes. And that cellular reprogramming is the ultimate metaphor for deep learning.
Oh, I love that.
You take a cutting of a brilliant idea you encountered in one context, you evaluate its underlying mechanics, and you plant it in the soil of your own discipline.
You're asking that knowledge to grow new roots in your mind.
Exactly. You deconstruct the vibrant yellow logic or the waxy, impenetrable evidence, and you figure out how to cultivate that exact same resilience in your own work.
Okay, wait, hold on. A single day.
Yeah.
I need to look at the exact wording here because this throws a massive wrench into that entire philosophy of propagation.
How so?
Well, Ang literally writes, it's a real pity that the blooms only last for a single day, as I've read.
Right, 24 hours.
After waiting since part 755, keeping that cognitive loop open for years, the payoff is 24 hours.
It seems short.
That sounds like a terrible return on investment for a gardener. Why put all that energy into evaluating, propagating, and reprogramming cellular structures for something that vanishes before you can even properly enjoy it?
That's a fair point.
Why not invest that scientific curiosity into something that blooms all year round?
What's fascinating here is that it seems entirely counterintuitive on a purely mathematical level. But the biology of a one-day bloom is an evolutionary marvel.
A marvel? How?
A flower is incredibly metabolically expensive for a plant to maintain.
Okay.
To create that vibrant yellow explosion, the Turnera ulmifolia relies on rapid cell expansion, driven by turgor pressure. The plant vigorously pumps solutes into the cells of the petals, causing water to rush in via osmosis.
So it's basically inflating the petals with water.
Exactly. The cells swell rapidly, pushing the flower open. But maintaining that delicate, high-pressure hydrostatic structure in the face of wind, sun, and potential predators, it costs an immense amount of energy and water.
So the plant intentionally pulls the plug on the flower.
It executes a process called programmed senescence. Once the primary goal is achieved, which is attracting a diurnal pollinator during that specific 24-hour window, the plant deliberately collapses the flower to conserve its resources.
Wow.
And this is where Ang resolves the paradox in the very next sentence of the journal, noting, still, it's a hardy plant that requires little to no maintenance.
The waxy foliage.
Yes, the robust, lipid-rich cuticles and the deep-rooted hardiness are exactly what pay for that fleeting, metabolically expensive day of blooming.
Oh, that makes so much sense.
It's a perfectly optimized, self-contained biological economy. The plant does not require constant daily agonizing intervention from the gardener.
It just exists quietly.
Gathering and storing energy efficiently through its resilient structures, and all of that unglamorous background automation is channeled into a single, highly targeted burst of peak performance.
Translating that biological economy into human performance completely changes how we should look at our own routines.
Yep.
We can think of this as creating asymmetric learning loops. The waxy leaves are your automated, low-maintenance habits.
The foundational systems.
Right. The systems you build that require almost zero daily cognitive load to maintain.
That framing of cognitive load is crucial. The human brain, much like the sage rose, cannot sustain peak metabolic output continuously.
We burn out.
Exactly. If you're constantly expending energy just to maintain your baseline operations, you have no osmotic pressure left to force a bloom.
Right.
By automating the heavy, robust systems in your life, you free up the mental bandwidth required for high-intensity, short-duration insights.
Which directly challenges you, the listener, to audit your own systems. Where are your waxy leaves?
That's a great question to ask.
What are the robust, unglamorous, low-maintenance foundations you have built that silently protect your energy? Think about a brilliant surgeon. They might perform a highly complex, life-saving procedure that lasts just a few hours.
Their single-day bloom.
Exactly. But that fleeting burst of peak performance is entirely supported by the hardy, low-maintenance decades of automated anatomical knowledge and sterile protocols they don't even have to think about anymore.
And yet, we culturally obsess over the bloom. We want every brainstorming session to yield a vibrant yellow breakthrough.
And we view anything less as a failure.
Echoing Ang's initial sentiment that a one-day bloom is a pity. But the biology proves that a 24-hour peak is not a failure.
It's a feature.
It is the mathematical reality of a healthy, sustainable system. You don't need to be at your absolute peak every single second, as long as your foundational roots and waxy defenses are hardy enough to keep gathering energy for the next cycle.
Bang clearly grasps this biological economy. That's why the entry doesn't end in disappointment over the ephemeral nature of the flower.
Right, and concludes with, so it's definitely something we can explore further down the road.
The fleeting nature of the bloom doesn't deter the master gardener. It justifies the long-term commitment.
Ang wants to evaluate and propagate the plant, not to force it to bloom forever, but to study the incredible machinery that allows something so hardy to produce something so delicate.
It is the ultimate synthesis of observation. The value lies in understanding the entire mechanism.
Recognizing that the background resilience and the foreground brilliance are not two separate traits.
They're a single, integrated strategy for survival and expression. Okay, let's take a breath, because we have extracted a massive amount of technical and philosophical insight from a very concise journal entry.
We really have.
So what does this all mean? We started by examining the sheer scale of a 910-part journal, mapping the psychology of the Zeigarnik effect to understand how keeping a mental loop open for years primes the brain for true discovery. We saw how Ang's patience culminated in a high-contrast visual encounter with the sage rose, sparking the expert's impulse to propagate.
To reprogram those to typidant cells of an idea so it can grow roots in a new environment.
Exactly. Then we explored the biological mechanics of turgor pressure and programmed senescence to understand the paradox of the 24-hour flower.
Discovering that this fleeting beauty is entirely financed by the plant's incredible, waxy hardiness and low-maintenance nature.
It is the ultimate blueprint for asymmetric learning loops, teaching us that building resilient, automated background systems is the only way to free up the cognitive load necessary for our own metabolically expensive moments of peak performance.
It is a remarkable density of insight. But before we conclude, I want to leave you, the listener, with one final dynamic to analyze on your own.
Okay, let's hear it.
It builds entirely on the text, but shifts the focus back to the author's timeline. Consider the fact that Ang titles this post Part 910.
Right, 910 entries.
After 910 chapters of meticulous daily observation of the natural world, Ang is still utterly captivated by a flower that vanishes in a single day and is already actively planning to explore it further down the road.
The learning loop never actually closes?
Exactly the point to ponder. What does that tell us about the architecture of human curiosity?
That's a deep question.
Here's the question to ask yourself. Are the things that fade the fastest actually the ones that demand our deepest attention?
Oh, wow.
Does the very fact that the bloom disappears in 24 hours guarantee that a true learner will never stop returning to observe, evaluate, and propagate it for another 910 chapters?
The ephemerality isn't a pity at all. It's the biological hook that sustains a lifetime of curiosity. You have given us an incredible framework to process today.
It's been a pleasure.
To everyone listening, thank you for diving into the mechanics of observation with us. Check your own mental browser tabs, cultivate your waxy foliage to protect your cognitive load, and keep finding those sudden, vibrant bursts of insight in your daily routines. Because deep understanding doesn't require a mountaintop epiphany. It just takes the rigorous patience to study the mechanics of what is blooming right in front of you, even if it is only there for a single day.